Good morning, SE student. This is your math teacher. Miss you all. This is the 6th week of quarantine. Today I'm going to solve two questions from the official exams. The first one, 2007 session 2, the second one, 2005 session 1. Of course, the problems concerning numerical sequence. The first question is about the manager of a sport club declares that every year 75% of the members renew their membership. This means that 25% left, and 800 new members joined the club. So in 2005, the club had 1,600 members. We can denote by UN the number of members in the club after n years, which means 2005 plus n. The first question is to verify that U1 equal 2000 and to calculate U2. The second one is to represent UN plus 1 in terms of UN. The third question, they gave us a new sequence, Vn, which is equal to 3200 minus Un. And then they ask us to show that Vn is a geometric sequence whose common ratio and first term are to be determined. In part B, express Vn, which is a geometric sequence, as I said, then Un in terms of n. We use geometric sequence properties for Vn, then we can deduce Un. The last question is it possible for the number of members to double? And that's what we are going to answer in this question. First of all, they ask us to verify that U1 equal to 2000. We know that 75% of the original number of members of the club remains, and the first one U0 it is 1600, I think. So I can write in this case use U1 equal U0 times 75% plus the 8 new members, so we obtain 2000. U2, it is in terms of the preceding year, which is U1. So U2 equal, using the same pattern, U1 times 75% over 75 over 100, which is 75%, plus 800. This becomes, and of course U1 equal 2000, this becomes 2300. Now they ask us to prove that UN plus 1 equal 3 over 4 UN plus 800. In fact, by using the same pattern, I can say that UN plus 1 equal 75% of the preceding year plus 800. So I can write in this case UN plus 1 equal UN plus 75 over 100 plus 800, which gives us 3 over 4 UN plus 800. Now in the third part, they ask us to take a new sequence, to consider a new sequence defined by Vn equal to 3200 minus Un, and they ask us to prove that the sequence is a geometric sequence. To prove that the sequence is a geometric sequence, we need to determine Vn plus 1. So Vn plus 1 equal to 3200 minus Un plus 1. Why is that? Since here I have Vn, Un, so if we put here Vn plus 1, it will be here Un plus 1. Then we replace UN plus 1 by its expression, which is 3 over 4 UN plus 800. We obtain at the end 2400 minus 3 over 4 UN. By taking 3 over 4 as a common factor, we obtain here 3200 minus UN, which is the same as Vn. So we can say that this is 3 over 4 of Vn. So I can write Vn plus 1 over Vn equal to 3 over 4 Vn over Vn, which is equal to 3 over 4, which is constant. So I can deduce that the sequence is a geometric sequence of common ratio 3 over 4. And the first term, of course, also by using this relation Vn equal to 3200 minus Un, we replace n by 0. So we replace here n by 0. We obtain 3200 minus U0, which is 3200 minus 1600, which is equal to 1600. Here they ask us to express Vn in terms of n. Since Vn is a geometric sequence, so I can write Vn equal V0 times R exponent n, which is 1600 times 3 over 4 exponent n. And since Vn equal 3200 minus Un, of course Un is neither arithmetic nor geometric. I'm not going to use the arithmetic, the properties of the arithmetic sequence or the properties of the geometric sequence to find to express Un in terms of n. But I can use this relation Vn equals, so I can transform the un to this part and Vn to this part. So we obtain un equal 3200 minus Vn, and already Vn equal 1600 times 3 over 4n. So we can replace this value, and this is Vn and un in terms of n. The last part, is it possible for the number of members to double? We know that the number of members is un, and to double from the original value, which is 1600, this means to becomes 3200. So I can write it un equal 3200 minus 1600 times 3 over 4 n. So by putting un equal un in this case, so we can cancel 3200, and thus minus 1600 times 3 over 4 n equal to 0, which is impossible because this is a negative quantity, this is a strictly positive quantity, this must be negative and not equal to 0. So the number of members cannot be doubled. The second question, a statistical study of the population of a certain village revealed the following information. The population of this village was 6,000 at the beginning of the year 2000. The annual increase in the population of this village is 2% due to birth. And 200 persons leave the village permanently every year, moving to town, immigrating, or whatever to other countries. Designate by un the number of inhabitants in this village in the year 2000 plus n after n years. Let u0, the original number, which is here the original number of inhabitants, equal 6,000. They ask us to verify that u1 equal 5,920. The second part shows that un plus 1 equal 1.02 un minus 200, and also here they gave us a new sequence un in terms of Vn, which is equal un minus 10,000. They ask us to show that Vn is a geometric sequence of common ratio and first term to be determined, and to express Vn in terms of n and un in terms of n. The last question is, during which year would the number of inhabitants in this village become less than 3,000 for the first time? The first question, verify that u1 equal 5,920. I can write it as 6,000 plus 6,000 times 2%, which is the annual increase, minus 200, the inhabitants that they leave the village. So we obtain 5,920, or I can express it like this, u1 equal u0 into 1 plus 2% minus 200. We obtain the same. Of course, I prefer to use this notation. Now show that un plus 1 equal 1.02 un minus 200. We use the same pattern, or I can use this way, and in the place of 6,000 I can put un, or I can use this way. Instead of u0 I put un, and instead of u1 I can put un plus 1. So we obtain un into 1 plus 2 over 100 minus 200, which is 1.02 un minus 200. What about the sequence Vn equal un minus 10,000? They ask us to prove that the sequence is a geometric sequence. So to prove it that it is a geometric sequence, we need to determine Vn plus 1 first, then the ratio Vn plus 1 over Vn. Since Vn equal un minus 10,000, then Vn plus 1 equal un plus 1 minus 10,000. We replace un plus 1 by its value. We obtain 1.02 un minus 10,200. We can factorize by 1.02. We obtain un minus 10,000, which is the same of the expression of Vn. Vn plus 1 over Vn equal 1.02 un minus 10,000 over un minus 10,000. Every time, the most of times here, we can factorize by the coefficient of un, okay, to obtain this Vn. So we can simplify here, and we obtain a constant term, which is the common ratio, and this is a geometric sequence of common ratio 1.02. If we need to calculate Vn in terms of n, since it is a geometric sequence, then Vn equal V0 times R exponent n, which is 1.02. But we need to know first of all the value of V0. Since Vn equal Un minus 10,000, then V0 equal U0 minus 10,000, which is 6,000 minus 10,000, that gives us minus 4,000. Vn equal minus 4,000 in this case times 1.02 exponent n, which is V0 times R exponent n. And since Vn equal Un minus 10,000, so we can deduce that Un equal Vn plus 10,000. We take 10,000 to the second side. And Vn, I have it already in terms of n, I replace it by its value plus 10,000. And this is Un in terms of n. During which year the number of inhabitants in this village become less than 3,000 for the first time. So we write the Un less than 3,000. Step by step, we obtain minus 4,000 times 1.02 exponent n equal minus 7,000. So 1.02 exponent n equal minus 7,000, or in fact greater than minus 7,000 over minus 4,000. Of course, the inequality is changed since we divide both sides by a negative number. We use len to find the value of n. We put len of the first quantity greater than len of the second quantity, then n len of 1.02 greater than len of 7 over 4. Since the quantity within the len is greater than 1, then this quantity is positive, so we can divide without changing the sign, of course, which is approximately, we obtain n greater than 28.25, then n greater than or equal 29. So after 29 years, in 2029, the population become for the first time less than 3,000. This is all for today. Thank you.